So welcome to the video lecture series on Introduction to Computer Networks. This lecture is going to cover the topic on Ethernet LANs. So to understand what the Ethernet LAN is, it is the most simplest form of network which connects end user devices to one another which are considerably close to each other. The term Ethernet here refers to a specific standard of networking which is set by IEEE, and the reference number that we use for Ethernet LANs is 802.3. So when we say that a particular LAN is an Ethernet LAN, it is pretty much the same thing as it is a wired LAN. Very simple network where all the nodes are pretty much close to each other. And this is also the most dominant networking technology today. If you would like to just look at the standards of LANs, there could be the Ethernet LAN, which is the wired network. The IEEE standard reference number for this is 802.3. The other form of LAN, which is wireless LAN or WLAN, the reference number for this is 802.11. The transmission type for Ethernet LAN is particularly based on the fact that it is wired, so therefore it needs to be able to communicate using electrical current. On the other hand, wireless networks or wireless LANs use radio waves. The primary layers which are focused with Ethernet LANs are the data link and the physical layer, which applies to both Ethernet and wireless LANs. And we will look at these later on, but these LANs, they have these collision detection and prevention techniques called CSMA-CD for Ethernet, and for wireless LANs it's called CSMA/CA. The CD is collision detection versus CA is collision avoidance for wireless LANs. The common name that we use today for both of these is Ethernet and Wi-Fi. And the advantage that we have for Ethernet LANs is that it is considerably stable. It's very easy to upgrade. It is not very it's specific to vendor technology, so it's kind of it kind of is able to work with a lot of devices, and it is compatible with a lot of other technologies. On the other hand, the simplest version of wireless networks, the WLAN, allows mobility. It is not that expensive either as well. However, the disadvantage with Ethernet LANs is that it has limited mobility, which means that we are only focused on networks which have the devices relatively close to each other. On the other hand, wireless LANs, they are not one of the most secure versions of wireless networks, and they still need some form of wired access point which allows the wireless nodes to be able to connect to the rest of the network. So if we look at the way that the Ethernet technology has grown over the years and the different versions which exist now, the Ethernet cable, there are three different versions. The 10 base T, 100 base T, and 1000 base T. The common names for these are Ethernet, Fast Ethernet, and Gigabit Ethernet. And if you see here, the speeds which are mentioned for each of these kind of Ethernet cables, that is the maximum allowed speed. That is not the default speed, but rather the max allowed speed for each of these cables which we can use. On the other hand, similar technology for cable connection, the fiber optics. There are two different versions, 10 base LX and 10 base 1000 base LX and 1000 base T. The two versions are different with respect to the way they transfer light. So the multimode fiber, which is 1000 base LX, this is considerably cheaper with a larger diameter of the fiber optic cables. And the reason why they have this is because it uses multiple points of light. It is it uses the regular LED lights, and if you know how light propagates, that is in pretty much all directions. So it has a wider core, and the light kind of spreads out across all directions and then travels through the fiber optic cable. The other version, the 1000 base T, is called single mode fiber, and it uses a laser light. And we know that laser is a focused light in a single direction, and therefore this version of fiber optic cable is considerably more expensive. However, it's with a smaller diameter core, and it can actually carry further than the multi-mode fiber version. So if we look at a very simple setup of a network, as you can see here, there are three different LANs which are connected with the help of switches in the middle. So for example, switch 1, it is connecting 6 network hosts, and then switch 1 is connected to switch 2, which again connects 3 more network hosts. So like this, the LANs 1, 2, and 3, they are Ethernet LANs, and these 3 LANs can be connected together with the help of a router. So in Ethernet LAN, there is something that we need to understand is that we refer to as the transmission mode. The transmission mode refers to how the different nodes are allowed to transmit data over the Ethernet cable. So to understand that, the most primitive version is what we call simplex, which means unidirectional communication. It's not really something that is applied in today's networking technologies, but that is one of the versions that we can think of. So simplex means it's just unidirectional. However, in the case of Ethernet, we are generally concerned with duplex connections, which means that both ends can send and receive. However, both ends cannot send and receive at the same time in the case of half duplex connections. So for example, in the diagram on the top, if these two nodes are connected with half duplex connections, each of these connections are responsible for transferring data from one node to the other. So TX means to send, RX means to receive. So if the server and the switch are communicating, the server sends a message which reaches the switch on the RX terminal, and then the switch can also send a message over from the switch to the server from the TX to the RX terminal. However, if both of them try to transmit at the same time, they run into a collision. So that is what the half duplex means. That means that at the same time, the two ends cannot be sending and receiving at the same time. On the other hand, for full duplex connections, the transmission can occur in both directions at the same time. So the transfer port on the server can keep on sending to the receiving port on the switch, and the transfer port on the switch can be sending onto the receiving port onto the server. And this can occur at the same time. So today, switches, routers, and PCs are mostly full duplex, but they also support half duplex connections. But for the most part, they are generally configured to full duplex connections. On the other hand, hubs, which is one of the primitive networking devices, one of the simpler ones, they generally support half duplex connections only. So now, given that two nodes are connected over Ethernet, there are these certain properties which needs to be exchanged and negotiated between the two ends. So the nodes needs to decide if the transmission settings on the communication are on the common ground, and then also the transmission speed and the duplex mode. So for auto negotiation to work, there is a protocol for auto negotiation, and both of these network ends must have the protocol enabled so that they can exchange this information. They send each other the highest speed that each of these ends can support, and then they agree on the speed which is common for both of them. However, if one of the nodes is not advertising its transmission speed, the overall transmission for that connection will fall to the default lowest speed, which is usually 10 megabits per second, which is not really a great thing. And therefore, auto negotiation helps you perform the communication at the optimal speed so that both ends can actually support and have it at their max capability. So if auto negotiation is not enabled, and if one of the nodes is full duplex and the other node is half duplex, they will not know when to send and when to stop, because one of them is capable of only sending and receiving at different times, while the other one can send and receive at the same time. So there will be a lot of collisions on the half duplex end, which cannot handle the transmission and the reception at the same time. So for Ethernet LANs, the cables that we use are connected through jacks which have 8 ports, and the cables are twisted pair cables, if you remember from one of the previous lectures. So there are 4 pairs of cables, which means there are 8 cables running between 2 devices. So there are 2 ways that we can connect devices in the Ethernet LAN. The first is relatively simpler, which we call the straight through cable. This means that the terminals 1, 2, 3, and 6, they're connected to the same terminals on the other end. You have to remember that straight through cable is suitable only if the 2 devices are different. For example, if a router is connecting to a switch, or a switch is connecting to a PC, or a PC is connecting to a router. So in any case where the 2 devices are different, they can connect with each other through straight through cable. In the second case, which is a crossover cable, terminals 1 and 2 are connected to terminals 3 and 6 on the other end. And that applies the other way as well. And this kind of cables are required when the 2 devices are same. For example, if we are connecting one switch to another, or we are connecting one router to another, in this cases we need a crossover cable. However, in today's world, most of these devices actually can identify the type of cable automatically, and it can switch between these 2 modes. However, the default setting for these kind of connections are set for straight through cables whenever the devices are different, and crossover cable when the devices are the same.